I proceed to the paper, maybe has anyone here have tried using any Gen AI tools, and what have you guys encountered on the prompts? Did you guys encounter some hallucinations? Maybe from the audience right here, like have you guys like try typing a certain prompt, but then every time you do the same or other kinds of prompts, the output seems to not show the accurate response from your question. Maybe you can type in if you guys have experienced it. Yeah. Just for me to know, like, how was the people? Like, if you guys encountered any kinds of it, yeah. So maybe you could also still type in. But right now, I actually experienced a lot of it in terms of, trying to input some prompt. And there were times that it was too, very far from the question that I asked. And usually do the prompting, the prompting that we know of. And I think right now, since we're now talking about retrieval augmented generation, it's something that people are, heard a lot, especially now that we're in the generative AI space. So just imagine here, the generative AI, it's really like a library full of different textbooks. And whenever we try to prompt something on ChatGPT, Gemini, or other tools, it usually first retrieves somewhere. It's a knowledge base. And then from there, it tries to just answer your questions based on the data that they have stored, some are like bigger ones. And then sometimes, whenever they do retrieving of any information related to some questions, there were times that the hallucinations came in, right? Maybe there's like some few context about the data. Let's say you ask about RAG. Sometimes when you ask ChatGPT what is RAG, it usually answers different things, or it usually answers related ones about retrieval augmented generations. So there were times that it happens a lot. So just to give you context. So when the concept of retrieval augmented generation, you wanted to specify that, try to solve the challenges in terms of hallucinations or not getting the right answers from your questions or making it more specific to the data that you put there. You wanted to, let's say, build something that could answer only specific questions about mental health. And you want to just focus on the different kinds of mental health issues, ways to help your mental health and everything so on. You don't want to use any generic ones, right? So that's one thing. So in the concept of retrieval augmented generation, you do what we call indexing. So let's say you wanted to scan or specifically find a book related to, let's say, Python programming, the oldest edition. But then again, you only have some ways to do that. You either scan different books about it using the catalog or search it on a database. And usually you can find ones, but sometimes you have to manually find it. So in the concept of retrieval augmented generations, you have already a database for that. All the things that you wanted to have your AI to answer with. So that's one thing. And then find something from there. So that's basically one examples of, retrieval augmented generation. It's just something like you have your own library. You want to find something, focus on that thing. And then from there, you get the answers related to the questions that you put and you store it on the database. So that's basically one, right? Before I go to the paper, just to give you guys some, a little bit, something to start on, right? So in the concept of retrieval augmented generations, there were something that we need to think about. We do have something like a data storage, wherein we store all the data that related to, let's say, some documents, whether it's specific to medical documents, whether it's financial data, and then from there, we build a specific or domain focused AI system, right? You don't want something that people put something that unrelated financial documents, and now the response may not be related to that, right? So you have your store there, all the kinds of documents. And then from there, once there is the user make an inputs, it basically retrieves, related documents based on the prompt, based also on the data you actually stored. So it's something like that, right? So it's more clear to set up. So I think, yeah, we can probably start on. Before anything else, you feel free to actually just share your thoughts maybe afterwards. So let me just share screen the paper and let's start with the paper itself. So if you see some orange stuff there, it's really more to highlight things, right? Because there's so much thing happening on one paper. So before anything else, maybe someone here can tell me, like, have you guys heard about retrieval-augmented generation or have seen it on the internet? Maybe you can type yes for the audience. Just type no if you haven't. Like you haven't read upon on it or it's your first time to actually see it. Yeah. Maybe you can type it for the audience. Okay, so I think maybe it's your first time. That's why you're not yet sure about it. So that's why I made an introduction about thinking about RAG as the library, wherein you want to scan documents and then really specify what you want to look for. So with the concept of retrieval augmented generation, so I did this actually I can also attach this file so that you could also try this one. Let me also upload it here, the document. Let's see. Okay, so I think yeah, I think I can also share it afterwards here. Yeah, so this is the paper. You can actually look through this. Okay. It's also sending, so you guys can download it. So yeah, this is the paper. I know that the organizer already shared this to you guys. So if you check it before our session. So basically for the concept of retrieval augmented generation, we do have what we call concept of retrieval process. So before anything else, just to highlight this one that we just showed this. When we say RAG, it's really more of information retrieval process, which enhances the generation process. So which means that you put specific context or data so that when you now prompt the question, it's a bit much easier to find it rather than not knowing what kind of data was stored in the database, right? With ChatGPT or other kinds of Gen AI tools, they're very generic. So a lot of people are prompting anything there. It might not be specific to what you want to do. So that's why you have to make something more specific. And then from here, just to get you started, there were some kinds of limitations that's happening in generic AI system or Gen AI system. We usually have some, yeah, hallucination is number one. Sometimes there was some sort of, context that doesn't have any information. That's why if you notice, with ChatGPT 3.5 or 4.40, we usually show some limitation on the data. They usually say that it's 2022 or we don't have any data beyond that. That's why it's basically something that it couldn't answer some of the questions you might ask, right? So that's one thing. And in the concept of it, before, we do have some, GPT before, we do have some Llama, we do have DAL-E. If anyone here have used, text to image models specific to DAL-E, and if you saw stable diffusion wherein you can actually, generate image there, and also Sora. I'm not sure if you guys can confirm if you guys saw the Sora before, the one that you can convert it into videos. That's also one thing that's happening recently with OpenAI as well. So in that sense, there were a lots of AI generated content that was happening. So that's the term with AI GZ. So they are really specific to some of the content that's generated by AI, right? That's one. And then, of course, just to go directly to this, I guess just to highlight this paper, this part of the paper, that the way we look at it with that, it's also helpful because it can actually reduce the large generative models. Because when you think about it, imagine you're going to be training, you're going to be using API of OpenAI, for example, and you want to fine tune it or use other kinds of LLMs. They're usually really big, they really are large. So it's really hard to train one. So that's why RAG is really more of trying to reduce the larger scope when you're training it and make it really more specific so that you have the process or you can control how large your data can be. That's one. And then of course I already show you guys the sample, visualization or the flow of it. But technically when you say RAG, it can also do text. If you notice some of the documents, let's say research, there was like some sort of tables, right? There might be some sort of image that has a text, and you wanted to just definitely understand what it does or what specific information there. So it can be actually done it. I think other than that, it's also more on, let's say, you have a document that has a lot of tables. and you just wanted to really abstract information from there, you could do that using the RAG method. I guess to put it simply, there is what we call llama index, wherein it can also work in that sense for the RAG itself. And of course, there was something more of, storage data wherein we call that vector database, or wherein we store there the vectorized, text from that certain document. And then from here, we have the generator. So that's where now it generates the response. So either it's Gemini. I think with Gemini, there's also one, it's Gemma, with OpenAI, Stability AI, and other things, right? There's so much models are happening, and that's why very overwhelming at first, especially for the students here, or yeah, wanting to try one. So yeah, that's one thing. And then also with RAG, everything came upon with what we call multimodals. So we can now see that text to video, text to image, vice versa, and a lot of things, right? It can actually do multiple tasks now compared before that. Let's say in the sense of machine learning, we do have specific target to think about. Let's say just wanting to predict whether it's an animal or a cat, right? Or animal or an object, right? Or specific things. But in the sense of generative AI, we can do now multimodals. It can do different tasks at a time, whether it's doing codes, whether it's doing something related with images, with audios, or generating text itself, right? So there was something more specific to that. And of course, just to get more of this, I think the thing about RAG is that it's really specific to queries. So you have to really ask the question and then make sure that you have a data that's stored on the database. Otherwise, it cannot answer the question you put right on the prompt. So it usually specifies to what do I want to store in the database and what kind of prompt do I want to have so that I could get those kind of data from the database. That's like something more of the question from there. But just to really take it, a really simple thing is that RAG is really more of query, right? We need to query so that we need to make sure that the output is really going to answer it based on the data that we stored on the database. So that's one. And then next here is probably this one. Just want to highlight this, that this paper is actually more of, they try to resurvey something about, RAG itself or any kinds of ways to have a guidelines for some of the, practitioners or researchers to actually apply it on their end. So there were like three things that they actually did here. They conduct some review and then try to do some, RAG foundations from there and, investigate different kinds of literature about RAG. And then, of course, they want to make sure that you're going to be focusing on the AI generated content, right? Wherein that's where we usually do with ChatGPT. Let's say you want to like get specific AI generated content, then post it somewhere else or like use it to somewhere else. So that's one. And then, of course, skipping this part, let's try to think about this. So in the past, before generative AI, we do what we call transformer, right? I know you guys have heard this a lot. We do have the birth models, or even the LSTM, right? And then also the gas. These are like the things that revolve around before generative AI, right? And also the diffusion models. So back then, we were trying to understand like what are the kinds of general architectures we can actually use from here. So yeah, just to focus on it, I guess to highlight this even more, with RAG concept is that you actually have something like an input query again, and then search for relevant information. That's one process. The second one is that you have an original query, and then the retrieval results are fed into the generator. For example, some people do store data. For example, the column looks like there's like an input prompt, and then there's like the output possible prompt from there. So usually some people do that as well. We have added some title or kinds of content, and then actually vectorize it so that the computer understand the text using the numbers, right? So typical way how we learn about machine learning, it usually converts that into embeddings before it really predicts something, right? So that's still one thing. And then the third is actually the generator produces the desired outcome. So that's like the three things about RAG itself. And of course, as I mentioned, we do have the transformer model. So this is very specific to the natural language processing thing, which is really one of the famous one is the BERT, right? Developed by Google. So it was really a good start because I mean you guys can remember the attention is all you need paper. Everything was there started. It started about how do discriminative models, which means that a 0, 1, true or false kind of option became more like a generative. And we are now creating something from there. That's one. And then for LSTM, it's really more of the RNN or the recurrent neural network, where it is actually more of specific to that case. And then going to the GANs, if you guys have heard some more of concept about deep fake, before GANs was actually being used to it because again, it's really too complex that it can actually understand, high quality or high complicated data. Specifically, let's say images. Some of it is also videos where you can actually make or create something like a deep fake of, like say, your face, and then tries to hack something like that. So GAN is also one thing. It's a generative adversarial network. And I actually been using it a lot before. And then when the generative AI came in, everything really changed a lot. So I'm not sure if you guys have experienced that as well. And then next is also this one. It's a retriever. So I think before anything else, yeah, if you guys have any questions so far, but I'm trying to simplify it so that you guys can also try it. So yeah, so I think with the retrieval, method about RAG itself, it can actually, let's say, I think to imagine it is like you're searching concept on the search engine, which is Google, and then you just wanted to show specific documents related to it. Sometimes it will show you the first 5 top most similar papers, let's say related to retrieval-augmented generation. So it will show you. So that's what it means when they say top K. So it really shows what's really relevant or really closest to the prompt. And then from there, the succeeding papers might be like some sort of, something like that, really closest, but not really that very high as well. So that's one thing. So that's really more of, yeah, I added some concept here, which is just imagine a library full of different textbooks. Usually, you're just gonna show some, when we see, let's say, addition of books, let's say we do have like edition 5, edition 6, and then you just wanted to like just search all the related, edition of the book. It will show you on the first browse, and then the rest ones could be just, a recommendation that you could, look at this and so on. So it usually have some keywords that it follows. So let's say you're looking for something, it usually just show keywords that could be, related to the search you put there. That's one. And of course, we do have what we call a sparse retriever. So it's more of like where the key values are represent as documents to the search, right? So it's more of like, it's easy because we can now actually just use it as a key value. So it's easy to like find it on the database by using your inputs. And then next is also, I think the next one could be the dense retriever. So it's still similar to the other one, which is the sparse, but it's more of the strict thing about embedding vectors, which is really more helpful for, just finding the accurate ones, in some sense that the computer does understand, the numbers, right? And compared to us that we can read up the text. So that's one. And of course, yeah, so the similar score between dense representation are usually computed with metrics. So it's just really a concept wherein it needs to have a scoring. Let's say I'm searching a retrieval augmented generation document. There's going to show a percentage. Let's say I've shown top 5, right? Top 5 papers. The first one could either have 95% closest to the prompt or the search. And then the other ones could be having like say 85% closest to what you put as input. And so on. So it has like some similarity scores to what you want to look for. So that's also one thing that related to the dense retrieval, specific to that. So that's one of the concepts. If you are guys familiar with the name entity recognition, that's also one aside of the similarity search. It also identifies based on some of the keywords, the entities from there, and then from there try to also do the same process as well. Okay, so I think just to go next one is that in the RAG concept, there were different types of RAG, right? So it's just okay. So something new, right? So we only know about the query base, wherein you put some query, and then the RAG will answer based on the documents you stored, right? That's the one thing. But there's also second one, which is the latent representative or representation based RAG, which means that based on the documents you stored, it now converts certain generative models as data representations. And then from there, it's really more of this a rather advanced little with the previous ones, but it can also do the same process as well from this. And then next is also I think just to give this one, I think the overview here is that you are also still checking depending on what kind of probably outputs you wanted to do. So I think let's try to put here now on the next one. So with the RAG enhancements, there is number one, the input enhancement. So again, even if we already try to minimize the data or really make it focused on some sort of domain, you still need to have some little bit enhancement, whether it's a prompting, whether it has to be trying to improve more the knowledge base or trying to improve the input prompts, anything so on. There's still so much thing that we could do. So as you can see with RAG, there's like input enhancement, retriever enhancement, generator, results, and then the pipeline. So it's like the entire process of the RAG, wherein you have some inputs. It's going to retrieve a document and then generates the response from there, get the results, and then now it's good. So the first one is really more on the input enhancement. So this is specific that we introduced this, the query transformation. So we wanted to, make sure that, we want some modification on the input query, whether it's something more of, I guess, more richness in terms of how closest it is. Let's say your data might be having medical documents, and in the sense of medical documents, there are a lot of things to consider, right? So you have to get the closest prompt you can get so that you can get the data you needed, right? So you have to transform your query. Second is the data augmentation, which is really something we know about, right? Let's say in the context of text, right? Let's say we do have the marigold, the poppy is on the space station. In the context of data augmentation, it can either get the synonym or try to do some transformation with it so that it can also, have something to introduce there. That, the marigold could be changed to something like other words, but still closest. And then you get more data increase, right? With something like that. So whether it's up to you what kind of way to increase the data just to get more, richness, it still depends, right? The next is the retriever enhancement. So this is more specific to how you're gonna get, the quality of the retrieved content fed into the generator. So of course, this one, it highlights that lower content quality increases the risk of the model hallucination. So this is very important to note about that even if we're trying to reduce the large language models into more specific, there's still gonna be hallucinations if there are no specific or no rich data that we can get from there. So you have to get more high quality data. It's like garbage out, garbage in and garbage out. So something like that. Next is also recursive retrieval. So it does use the concept of chain of thought. So if you're familiar with prompting, we do have zero shot. We do have the other one is the chain of thought, then other kinds of prompting process. With chain of thought is that you're giving some kind of steps that the prompt would follow so that when it generates the response, it's really specific, right? So you have to provide content, you provide samples, you provide step by step in that sense, right? So that's one. I think with this one, I think upon seeing this, it still also uses some Monte Carlo research, but yeah, let's skip that part on that sense. And then chunk optimization. Since I mentioned previously the chunk optimization, wherein it tries to chunk size the documents so that it improves the retrieval results, right? One example here is the Llama index. So they are very popular in terms of the RAG methods because they are very finer grained, which means that you're really trying to make sure that it be processed first before it goes to like the output part, right? So they actually do that, having a text chunks of it. Next is the retriever fine tuning. So it's still important to actually do that because again, at the end of the day, we have to do fine tuning, right, to make it really specific to the data we uploaded. And then the hybrid retrieval. So again, from here, it's a mix of it, right? We do have, both the dense retriever and the sparse retriever to improve the quality of retrieval. So we do use the embeddings, then we do the other one as well. So it's a mix of it so that, the output still as close as we are. So I guess based on the ABCD, it still depends on your context. So some of them might just focus on data augmentation because of some concerns. Some people might just use the chunk optimization because they feel like that will really help, especially when you're using Llama Index, right? So there's still so much things to think about for this one. The next is the re-ranking. So actually, a lot of papers were actually introduced with re-ranking. So from this one, it's really more of they try to reorder the retrieve content to get more diversity and better results. So some people, use it a lot when they see that even if they already, do the embeddings, store a lot of data, but still not getting the right answer from their prompt. So they do re-ranking just to get more, improved response as well. Next is also retrieval transformations, wherein from the word itself, you actually rephrase the retrieved content and then activate this one potential resulting in improved output. That's also one. The other one is really more of, I guess, at the end of the day, we still need to be thinking about prompt engineering or the prompting. Because even if we do RAG or use other LLMs, if we do not know how to prompt, we still always get the hallucination. So you still have to use the best of it by using your prompt. That's why there's so many kinds of prompting. Let's say zero shot, where you ask question or directly ask it. Then you do have chain of thought that's really specific to putting some context or samples. And then you do have few shot that already have some questions and then the instructions. So there was something more of prompting based from there. And then of course the decoding wherein we try to help, at least add some part where it decodes, the data that we put there. And then from your generator, that's where the output looks like. And then the result or enhancements, it's really more of even if we need to think about that sometimes the output from the RAG might not be still, better. That's why you still have to improve it as much as possible, even after we did it as well. And then output rewrite. So, rewriting the content generated by the generator in certain scenarios to meet the need of downstream stacks as well. Those are like the things for the retrieval. So I think this paper is really highlighting that even if you build something really good drag, you still need to improve it and enhance it really well. But it depends, right? So if you're using some sort of, wanting to just focus on data augmentation, maybe just improve the inputs from there, or so you still consider what kind of thing you wanted to improve on. And then next is also, given that we know that those are like the enhancements we can do, what we can do now for the RAG is really to optimize the process of the RAG system. So first is the adaptive retrieval. So yeah, so here some studies on RAG suggest that retrieval doesn't always enhance the final results. So you have to either, delve into something more of rule-based, right? Machine learning is really rule-based, right? So you have to put something like an inputs or targets and then so that the output would likely to show whether it's labeled, right? So something like that. So from here, it's the first one, the rule-based. Second is the model-based, wherein it's a self-drag uses train generator to determine whether to perform a retrieval based on the retrieve token. So we either have that. It's like two things, right? It's rule based and then also the model based as well. Then next is also the iterative RAG, wherein it refines the results repeatedly, cycling through the retrieval and generation phases. So it's like it doesn't stops with how the response already output. So it still continues to refine from there. So actually, I usually use the rule based when I'm doing RAG, instead of using the iterative RAG. But I think it depends on your biases, which one you use the most, or if you wanted to try, the easiest one for now is the rule based. And then if you try to improve it later on, you can do now the model based and then the iterative as well. And then of course, I think one example here that we put is the more in the side of the codes, right? Code completion, right? So generated code to better utilize, dispersed information. And then next is also the application side. So right now, one example we might have, if you're still confused about RAG, is the question and answering part, right? Let's say you do build something like trying to answer the medical concepts, right? So the process there is that you ask questions and it's going to respond from the questions and the process goes on, right? So that's one thing. That's one example for the RAG vertex. The second one there is also this. So there's like a lot of things, right? You have question answering one, machine conversation, summarization is also one. These are also more of the use cases around the RAG itself. So you can do code generation. Some people have built like they wanted to like put your GitHub there or the repository and tries to understand your code. Some people do that as well with RAG so that it's really customized with your codes. Some people use it for code summarization, code completion, RAG for knowledge, knowledge-based QA, knowledge-augmented. So I think as we can see here, we do have our text, we do have our coding, we do have our knowledge, image, and then science. So the science part is very specific to, let's say, math. Well, although some AI tools are not yet good with math, right? Because it's still probabilistic, but it can answer some of the questions. Drug discovery, biomedical information enhancement, and RAG for audio or in audio generation and audio captioning. So there's like some of the applications that we can use with RAG. So if you're wanting to like have some project related to Gen AI, I think the first one to try on is RAG because it's really popular now with industry. Because some industries, they really wanted to focus on one domain. You don't need to use very generic models and that has generic data. They really wanted to really customize it based on their needs. That's one. And then also, skipping that part, maybe we could go to this one. Yeah, so that's like the video. I think this one is for the text to video ones, wherein you have some sort of, the descriptions, and then you have a video database for that, and then from there it generates the specific snippets of that certain, prompt that you put there. I think I think it's really a good paper actually, to be honest, because when I was trying to look further about RAG, there were some parts of the paper that really talks about more than that. It really talks about like what kind of options you can actually use from there. So you can actually use this, afterwards, or if you're gonna build some papers from there. And of course, there's so much gaps that we find it very interesting. The first one is actually more of the noise and retrieval results. It really happens a lot. Like even if you really reduce some of it, the moment that you use the RAG, there's still some, because when we talk about Gen AI, we're not just talking about the accuracy, right? We're talking about how the output really are accurate, right? We're measuring now the context of the output. So that's still something that we talk about. Next is how it reduced or the generation cost, right? Because again, building generative AI tools or models or using it for our workflows is still very expensive, right? And the cheapest way to do it is to use the RAG because you don't use the bigger ones. Next is also the gap between retriever and generator. So you can retrieve, but sometimes the generator does not have that capability. So those are like the challenges. Increased system complexity, it happens a lot. Lengthy context. This was something, we really experience a lot, right? That shortcomings might happen is that if you have, lengthy context and you do have wanting to focus just, some sort of from there, when you're using Clearbase, for example, um, well, directions could be design of augmentation methodologies. It's really like more of adding more data sets on your certain knowledge base so that it get more, reach on the certain context. And then RAG pipelines really helpful because again, as we discussed previously, um, we do have, RAG for text, we do have RAG for image, videos, and a lot of things, right? So it really boils down that we do have some things from there. And I think with RAG, we can now apply it to any kinds of industries, but there's still something you need to improve from there, right? And of course, this one is really important. You don't just build for a practice, you build it for production. So you have to think about what you use from there that users can also use it. So Llama Index, LangChain, um, I think a lot of the other things, but those popular thing is like Llama Index and LangChain. So they are really good from there. Yeah, I think the PyPrab is also one. And then also, I guess this one is also important, having the long-term viewpoint knowledge so that it doesn't end from what you stored. So it's gonna, have some, let's say we think about ChatGPT, right? There are times that if you don't have any premium account from there, the data might just be limited to the year that we actually produce it on the basic ones. Usually it's just 2022, 2021. The rest of the years it doesn't have any data, right? So you have to think about, maybe you should use the premium one so that I could, try from there. And other techniques with RAG. So I think at the end of the day, I guess the goal here is to understand when to use it, where to use the RAG, and why you're gonna use it, right? Some people just wanted to use it for a reason that they wanted to improve hallucination. That's a good one to actually use for. Second one is that you wanted to focus on some domain. You're wanting to build mental health, specific RAG, financial RAG, or any kinds of topics. You don't want to use the generic one, so you're gonna be using RAG. Third could be that you wanted to utilize the cost. You wanted to just minimize the cost that you would need building it. So I guess also one, right? Because again, when you look at OpenAI, right, sometimes the API cost really expensive, right? Some people doesn't have that much budget with it, right? So okay, so yeah, I think that's one. I guess yeah, this paper really like a good one. But there were so much more papers that we could reference. But I think this one is gonna be like a basis to learn RAG from the start. So yeah, I think that's pretty much actually with my presentation. Yeah.
Okay, I mean, really thank you for your fruitful discussion. Actually, I am a new to the RAG, so it's like quite interesting to me. I got a lot of things from your presentation. Thank you. So yeah, we have got a question in the chat box from Miss Nya Isan. So she want to know that like how we can improve the input quality to enhance the RAG. Yeah, in the paper, there are several factors that can improve the RAG performance. And then I would like to know which one will be the most important factors to reduce the hallucination based on your experience.
I think for me, I usually it still depends, right? Some data might doesn't. Let's say you have working, let's say medical documents. So you really need the entire document of that medical. Instead, let's say we talk about financial data. You don't just need all the entire history of everything just to get that, right? So it depends on the context and what the goal there is that is to choose which one. I think when we look at the different kinds of ways to improve that, I think it still depends. So I can't really say how to improve hallucination because sometimes you just need more data for that, the context of data. I think you need just to really fine tune it more specific to that. I guess the gap with the generic ones, the general public kind of AI or Gen AI, that they cover a lot of things that it doesn't specify strengths already. Like sometimes in Gen AI or the AI system right now, they're good with coding, but they're not good with, let's say, doing math, for example. So I guess it depends in the context. And then I guess more of, yeah, it's still, yeah, something like that. So yeah.
Okay, thank you. So is there any more questions? Maybe you can ask in person or send in the chat. So, Ami, is there any resource you want to recommend to study more about the reg? I mean, the online course or something like that?
Yeah, I think
Yeah,
very interesting question. Yeah, for the one. I guess
yeah.
maybe you could start creating one. I think
Oh,
that's where you
okay.
can see the
Yeah,
gap.
yeah.
Like,
Got
okay, yeah.
okay. So we got another question from the Miss Eileen Mo. So RAG is very effective way, but I think it takes more time than usual generation because it has retrieval and generation. So she want to know how we can handle the latency.
I think that's where, it depends on the environment you train on. I think right now it's really cloud-based for this one. So I think it really helps because when you're using cloud-based, technologies when building the RAG, it's much faster comparing it to just doing it locally. And then the context of retrieval, the reason why it's really taking so much time, it's still because you still trying to retrieve the context from that certain prompt, right? And then you do have the generation. So it really takes upon some time to process on. That's why it's better to whenever you're building it, try to have some like an environment, a cloud, so that the latency can be reduced when, right? So I think my usually I did use a lot, sometimes GCP, sometimes AWS, both of them, because I need to first look at like, let's say I do have some data that's like really thousands. And usually the processing time when I do it in local, it really takes so much time. Just really one prompt, it takes so much time. And I guess that makes sense like why it's really expensive, like using the generic ones of LLM. So RAG is much better, much faster actually. I think you can use APIs from here if you want to reduce the latencies. If you want to, I guess Llama Index is also faster to use. I think just to share that one, let me actually try to show that one, the Llama Index. So just to get you guys try that as well. Yeah, let me try to share that one. Okay, so this one is actually the Llama Index. So they're really good with RAG. So if you have the problem with latencies, I think you could use this very much faster. So whether it's really structured documents, unstructured documents, or really mixed.
I think we lost the speaker. Let's wait for her a little bit.
Hi, can you hear me?
Hi.
Yeah,
Yeah. It's okay.
yeah. I got
Yeah, we can hear
disconnected
you.
for a bit. Yeah.
Okay. Yeah, that's fine.
Oh, yeah, sure. Let me continue the other one that I was after sharing.
Okay.
Yeah, I think it's the Llama Index.
Yeah.
Let me share again. There's this one. Maybe for those starting out, it's really a good one because it's still a package in Python. So if you're wanting to learn from it and try to actually apply in it for your project, just use this certain library there, and you already build RAG from there actually. So yeah, that's like the easiest one. And then yeah, I think that's pretty much for that one. Yeah.
Okay, thank you. Are there any more questions from the participants? So, I mean, I have one question. Like, in terms of the textual data, how do we handle for the language? We have a lot of like the semantic rich language, like Burmese, for example. Like we can have many words that have the similar meaning. For example, like beauty is equal to the pretty, or something like that. Yes, that happens a lot in the SEE language. So that kind of languages, which kind of model you would like to recommend to retrieve the best result?
Well, I think for now, I
Yeah.
guess the GPT is really helpful. Second one is
Mm,
actually the Gemini. They're really good
okay.
for the RAG. I think it's either up to them, but other models you could explore that. I guess it depends on which one is available open source, right? Because
Mm,
sometimes you have to use API first before you can use it. So I think find something that's easy to apply, whether it's Mistral, but also the other
mm,
one. Um, the other LLM models could be useful as well. So yeah, anything that could, I think some people do examine all, and then you just have to select which ones would be best for their use case as well. So
thank you. So, yeah. Are there any questions? Maybe no. So, I mean, thank you for your presentation and coming to the Women in AI Myanmar. Yeah, so maybe we hope to see you again in our future events. Thank you and see you, Amir.
thank you so much. Thanks so much.
Thank you.
Thank you so much.